You built a Telegram bot. It works. And somewhere in your code, there is one long string that bot father handed you when you created it. That string feels like a boring setting, the kind of thing you copy once and stop thinking about. It is not a setting, it is the whole password. Anyone who holds that string is your bot, with every right your bot has, and they do not need anything else. People paste it into code, commit it to a public repo, drop it into a chat to ask for help, and it leaks in minutes. Then a stranger is quietly running your bot and you are the last to know. I run managed Telegram hosting on dedicated hardware here in Singapore, which means I host bots and the secrets underneath them for a living. I have watched real tokens leak and I have seen exactly what happens next, which is usually nothing dramatic at first and then something very bad all at once. This is not a scary story to sell you a product. It is the plain boring security that keeps a bot yours, and almost nobody talks about it until the day they wish they had. So here's the plan. What the token actually is, because the answer changes how carefully you treat it. The handful of ways it leaks, all of them ordinary. What an attacker can do the second they have it. How to store the token so it never leaks in the first place. Why giving your bot the least power it needs makes a leak hurt less. How to rotate the token the moment it is exposed. And where the secret should actually live, which is the part managed hosting is really about. Start with what the token is, because it is simpler and scarier than most people assume. When you create a bot, botfather gives you one long string and that string is the entire credential. There is no separate username, no second password, no login page, no two-factor prompt sitting in front of the bot itself. The token alone is full control. Telegram identifies your bot by nothing but that string, so possession is authority. Whoever holds the token is treated as you completely, with no further question asked. That is the mental shift that matters. A token is not like a config value you can leave lying around. It is like the only key to your front door, cut once, with no lock you can change from the inside except by throwing the whole key away. Every place that string exists is another place it can leak from. And the internet is extremely good at finding strings that look like bot tokens. Treat it with the respect you would give a real password, because functionally that is all it is. Now the ways it leaks, and none of them are exotic. The most common by far is hard-coding the token straight into your source and then pushing that source to a public repo. People assume nobody is looking at their small project. Everybody is looking. Automated scanners and harvesting bots crawl new commits constantly, and the committed token is often found within minutes, not days. The moment it lands in public history, treat it as gone, even if you delete it a breath later, because someone already grabbed it. The second common leak is help. You hit a bug, you paste your code or a screenshot into a forum, a chat or a support thread, and the token rides along in plain sight. You get your answer, you fix the bug, you feel good, and you never rotate the token that 100 strangers just saw. Screenshots are the sneaky version of this, because the token is right there in the image and no search tool warns you. If a token has ever appeared in a message you did not fully control, it is exposed. The rest are quieter but just as real. Baking the token into a client-side app or a web page where anyone can open view source and read it straight off. Leaving it in shell history, in plain logs, in an environment dump, or in a config file with wide open permissions that half your server can read. And handing it to a contractor or a teammate who keeps a copy long after the project, and long after you stop trusting them. Every one of these is a normal Tuesday, not a movie hack. So what does someone actually do with a stolen token? First, they read. With a token, they can pull every message your bot can see, in every chat your bot belongs to. If your bot sits in a private group or a support channel, that is your users' conversations, quietly readable by a stranger. Nothing looks wrong from your side. There is no alert, no failed login, no trace in your own chat. The bot behaves normally because, to Telegram, the attacker is the bot. Then they send. This is the ugly part, because they can send messages as your bot to your own users wearing your bot's name and whatever trust it has earned. Scam links, phishing, malware, a fake announcement that your service is moving and here is where to log in. Your users have no reason to doubt a message from a bot they already follow. The damage is not just technical, it is reputational, and reputation is the one thing you cannot revoke and reissue. Istopititism envian solpitigenda naumi idembema. If your bot is an admin in a channel or a group, a stolen token inherits all of that. The attacker can post, pin, delete other people's messages, ban members, change the group settings, and generally run the place. A bot that was granted admin for one small convenience becomes a full takeover the instant its token leaks. The blast radius of a token is exactly the blast radius of everything you ever let that bot do, which is why storing it right is the whole game. Never put the token in your source. Load it at runtime from an environment variable or a small secrets file that lives outside your repo entirely, so the code you share never contains the string. This one habit removes the single most common leak completely. Your code can be as public as you like, and the secret simply is not in it. That separation, code in one place, secret in another, is the foundation everything else sits on. Then close the smaller doors. Add the secrets file to your git ignore, and actually check your commit history to confirm the token is not already sitting in an old commit before you push anywhere public. Lock the file permissions so only the process that needs the token can read it. Keep it out of your logs, because a token that gets printed once lives in that log forever. And keep it out of any URL, because a token in a query string ends up captured in access logs and proxy logs all the way down the chain. There is a second layer that softens every leak, and it is least privilege. Do not make your bot an admin of everything out of reflex because it was easier during setup. Grant it only the rights it genuinely needs to do its actual job and nothing more. Leave privacy mode on unless the bot truly must read all group messages, and understand that turning it off widens exactly what a leak would expose. A stolen token on a narrow, low-privilege bot is a scare you clean up. The same token on an all-powerful admin bot is a disaster you explain to your users. Now the part that saves you when prevention fails, because someday it will. If a token leaks, you rotate it and Telegram makes this clean. Botfather can revoke the token and reissue a new one, and the revoke kills the old string instantly. The stolen copy stops working the moment you do it, no matter who holds it. So the rule is simple. Rotate first, investigate second. Do not spend an hour deciding whether the leak was real. Assume any exposed token is already burned, revoke it, and then go look at what happened with the pressure off. Rotating is only half done until the new token is everywhere your bot actually runs. Update it in every deployment, every server, every copy of the service, and then confirm the old one is truly dead by watching a request with it fail. A common mistake is revoking, breathing out, and forgetting that a second instance somewhere is still holding the dead token and now silently offline. One token, one source of truth for it, updated in one motion. If you cannot say where all the copies are, that is the real problem to fix. All of which leads to where the secret should live. Because storage is not only a file path, it is a place. A token on a laptop is a token that walks out the door when the laptop does. A token on a random shared box is a token sitting next to strangers you cannot see or audit. The calm version is a bot on hardware you actually control, on a stable IP that stays reachable, with the secret held somewhere watched rather than somewhere forgotten. And it is not only about theft. A laptop dies, a free tier box gets wiped, a cloud account lapses, and the token vanishes along with the bot people were relying on. A place you control means the secret survives the hardware, gets backed up on purpose, and has one short list of humans who can reach it. Custody is the thing, and custody is boring, which is precisely why it gets skipped. Let me be clear about scope, because it matters. Everything here is about protecting a legitimate bot that you run and stand behind, a support bot, a community helper, an automation that is genuinely yours. It is not about harvesting somebody else's token, or hijacking a bot, or writing trust you did not earn. A bot token is a password, and the entire job is keeping your own password yours. The people scanning public repos for loose tokens are the reason this video exists. Do not be their supply, and do not become one of them. So that is the shape of it. Your bot is only ever as safe as the one string that controls it. Keep that string out of your code and out of your screenshots. Give the bot the least power it needs so a leak stays small, and rotate the instant it slips instead of hoping nobody noticed. Do those three things and you have closed the doors that actually get walked through. Telegram Vault is managed Telegram hosting on dedicated Singapore hardware. Real handsets on real carrier SIMs from Singtel, M1, StarHub, and Vivify. Your bots and accounts live on clean, stable IPs with the boring custody handled, secrets kept on hardware you control, and we watch around the clock, instead of a token quietly sitting in a public repo or on a laptop that leaves the building. If that is what you want, start at telegramvault.org. Onboarding begins with a real conversation about your setup, not a checkout page, and the code TGYT gets you a discount when you start. If this made you go check where your own token is actually stored right now, then it did its job, and you should probably go do that before you forget. Subscribe, because there is a lot more on running Telegram accounts and infrastructure cleanly coming on this channel. Thanks for watching, and I will see you in the next one.